Exchange reactions. I want to take a look at working with exchange reactions and predicting products. You can use this on the fill-in sheet. My example for an exchange reaction will be using calcium nitrate and sodium carbonate. What you should see on your sheet are the names for these two reactants, and again they are our starting materials, so they are the reactants, and this is what we're going to call a word equation. From this word equation you should be able to determine what the products could be. Now this doesn't guarantee that the reaction occurs, but as an exchange reaction they're going to exchange partners. So calcium is going to end up with carbonate, sodium is going to end up with nitrate. So we can write down our two products, which will be calcium carbonate and sodium nitrate. Now these are our products, and we want to check the products for solubility, and we want to use our solubility rules. And if we use the solubility rules, I'll look at calcium carbonate first. When you go through the rules, and you should have looked at this YouTube previously, when you go through those rules you'll find out that most carbonates are not soluble. So this compound is going to be a solid, and we're going to call this a precipitate. And I don't know if I spelled precipitate right. When we look at sodium nitrate, we're going to see that all sodium compounds are soluble, and also all nitrate compounds are soluble. So this should be real soluble. So this is soluble, this is aqueous, this is soluble. By the way, both of the reactants were soluble. This was a nitrate, this was a sodium compound, so both of these were soluble. So we would call them aqueous. Now that we know that we have a precipitate, this is one of the things that we need to look for in exchange reaction that says that the reaction occurs. Because the reaction occurs, we're going to write a balanced chemical equation for this. So to write a balanced equation, the first thing we need to do is to write formulas for each compound. Calcium nitrate will be made of calcium plus 2 ions, because calcium's in group 2, and the nitrate is a polyatomic ion, which is NO3 minus 1. The sodium carbonate comes from sodium in group 1, and the carbonate is a polyatomic ion. When I put these together, I need to cross charges, so I will need 2 nitrate ions. For the sodium carbonate, I will need 2 sodiums to match up with 1 carbonate. And then the two products are calcium, again at +2, carbonate at -2, which match up, and sodium at +1 and nitrate at -1, and again these two match up. I need to balance this equation, and probably the easiest thing to see is the sodiums. I need 2 sodiums. I will put those 2 sodiums in by putting a 2 in front of sodium nitrate, and what you'll notice that also does is it doubles the number of nitrates which match over here. This reaction occurs because we get a precipitate, So when I put in physical states, the three that are soluble we list as aqueous, and the one that is a solid we list as an S. Now, in some circumstances, had I had calcium nitrate plus sodium chloride reacting, I would have gotten calcium chloride plus sodium nitrate, and everything here is soluble. And because everything is soluble, we list this as a no reaction. What really happens is you put a bunch of ions in solution and you just have a mixture of ions. You don't have any, there's no chemical change occurring. And this is no reaction because everything's soluble. You know, to get a reaction, we're looking for a solid, but also if you form a gas, if you form water, or weak acids or bases, this allows exchange reactions to occur. But this is an example of how you write a word equation and then a balanced chemical equation.